Welcome to switzer.com. Here in this video we're going to discuss about thermochemistry and the thermochemical equation. Thermochemistry is the study of heat change in a chemical reaction. We know when reactants combine and form the products, heat is either given out or it is taken in. So in thermochemistry we study about the heat change, energy change during the chemical reactions. Now what's the thermochemical equation? Thermochemical equation is a balanced chemical equation that includes the enthalpy change, that includes the energy change. Normally when we write down the reaction, suppose we're going to write down a reaction here, hydrogen and oxygen, when they combine and they form the water, we often try to balance the equation, right? So this is not a balanced equation. If I try to balance it, let me take it, this is 2 times and this one also 2 times, right? Well, this is a balanced chemical equation, but here in this chemical equation I have not mentioned yet about the energy change. Now if I mention the energy change during this chemical reaction, whether the heat is given out or heat is taken in, right? Suppose here in this chemical reaction we know that this is an exothermic reaction. When hydrogen reacts with oxygen, this is a combustion reaction, right? And so a lot of heat energy is released during this chemical reaction. So that means the delta H enthalpy change will be negative for this reaction, right? So that means here for this chemical reaction we find that around 571.6 kilojoules of heat is given out. So that means in this chemical equation, now when I mention the energy change also, this equation becomes a thermochemical equation. Here in this chemical equation we have balanced the atoms and we have mentioned that the energy change also during the chemical reaction. So this becomes a thermochemical equation. A thermochemical equation is a balanced chemical equation that includes the energy change, that includes the enthalpy change during the chemical reaction. And as we know that when reactants combine and they form the products, either the energy will be given out or it will be taken in. So when energy is given out, that means the reactants have the energy higher than the products. Alright, when the reactants have high energy and the products have the lower energy, therefore the energy will be given out. That means the reaction will be exothermic, right? So here the delta H for this type of reaction will always be negative. Here's an example of an exothermic reaction. Ethanol, when reacts with oxygen and forms carbon dioxide in the water, so lots of heat is released here, right? 1367 kilojoules, that much of heat is released. So that means this reaction is an exothermic reaction. And when reactants have low energy than the products, so that means reactants can convert into the products by taking in, right? By taking the energy, by absorbing the energy. So that means this reaction is an endothermic reaction. So in an endothermic reaction, energy of the reactants is lower than the products. Here's an example. Calcium carbonate decomposes to the calcium oxide and the carbon dioxide, and it takes a lot of energy, 178 kilojoules of heat absorbed, and only then these reactants can convert into the product. So this is the thermochemical equation. This is another thermochemical equation. So that means in a thermochemical equation we mention the energy change, we mention the heat change during the chemical reaction. Hope you got the concept. Thanks for watching the video. Bye for now.